Right then, we'll start.
Yes, sir.
Yes. So, in the last class, I think we discussed about the types of solutions, no? Saturated, unsaturated, supersaturated, we discussed.
Yes, sir.
All the three discussed,
Saturated only, sir.
Only saturated we discussed.
Sir?
Only saturated we discussed,
Yes, sir.
Okay. So, once again we discussed the saturated, unsaturated, supersaturated. So, here, based on the solubility, okay, solubility, here the solutions are classified, okay, into three types, okay. One are called saturated, and second one are unsaturated, and third one are supersaturated. Okay, so these are the three types of solutions are there: saturated, unsaturated, supersaturated. Saturated means what? A solution in which no more solute can be dissolved at a given temperature. Means at one particular temperature, when you add the solute continuously to the solvent, then what happens? A solution is formed, and in that solution, if no more solute can be dissolved at a given temperature, that is called a saturated solution. So the meaning is what already we discussed, but once again, so when you take a beaker, okay, so this beaker consists of 100 grams of water. Let's think, okay, this is 100 grams of water, okay, of water. Now, as I told you that it can dissolve some 36.5 grams of salt in it, okay. So 100 grams of water capacity is 35.6 grams of salt, okay, sodium chloride will be dissolved, okay. Now for example, if we add this, we made a solution, okay, like 35 grams of salt we added in this 100 grams of water, and we stirred it. So then what happened? This total salt is dissolved in it, okay. So the total salt, 36.5 grams of salt is dissolved. Now what I do, I take more 1 gram of salt and I drop in this solution, more 1 gram extra now, okay. Now if I stir, does it dissolve? Yes, does it dissolve?
No, sir.
No, that will not be dissolved. So if when you add some, okay, extra salt, that will not be dissolved. It will be an undissolved state only. Even if you stir for a long time also, it will not be dissolved, okay. Now for example, if you filter this one, okay, if you filter this one, then what you will observe is that excess of salt will get filtrated. Excess of salt what we added, that got separated. Only 36.5 grams of salt, okay, solution only we can get here, okay. So this solution is called saturated solution, okay. Saturated solution means what? In which no more solute can be dissolved, okay. So how much it can able to dissolve, and that up to its capacity that salt is dissolved. So such solution is called saturated solution. Is this clear to you now? Saturated solution.
Yes, sir.
So definition is what? A solution in which, okay, no more solute can be dissolved at a given temperature. Okay, is known as saturated solution. So a solution in which no more solute can be dissolved at a given temperature is called a saturated solution. Then what is unsaturated? So unsaturated means what? The solution in which the amount of solute dissolved, the dissolved amount of solute is less than required for saturation. Okay, less than required for saturation. So how can the definition I write? So that afterwards I'll explain you. A solution, okay, in which, okay, the amount of dissolved solute, the amount of dissolved solute is less than required for saturation. Okay, so a solution in which the amount of dissolved solute is less than required for saturation. Means, for example, if I am taking the 100, okay, once again, so I am taking 100 grams of water. In that, for example, okay, for example, if I add only 20 grams of salt, for example, you think, okay, I have taken 100 grams of water, in that I have added only 20 grams of salt. Okay, now, but what is the capacity of water to dissolve the amount of salt? 36.5 grams. Yes, 36. But how much salt is there now inside? 20. So for saturation it requires 36.5. For saturation it requires 36.5. But amount of solute is 20. The meaning is what? That is less than required for saturation. So it's required 36.5, but now it is only 20 grams in it. So the amount of solute present inside is less than required for saturation. So less than saturation. So that is called unsaturated solution. Is this clear to you? Unsaturated?
Yes, sir.
Now for example, if I make this 20 as a 30, now what do you call this solution?
Unsaturated.
Unsaturated only. If I make it as 36, then unsaturated only, because 36.5. So here if I add 36.5 now, now it is saturated. Did you understand the difference between saturated and unsaturated? Yes. Now let us come to the supersaturated solution. So how can you define now a solution in which amount of solute dissolved, amount of dissolved solute, all right, is more than, okay, more than required for saturation. So here, for example, a liquid is there, okay, so a solvent is there, its capacity, for example, let's take this only, 100 grams of water is there and its capacity is 36.5 grams of salt only, it can be dissolved. But for example, okay, for example, just imagine that if the salt solution contains 100 grams of water in which some 50 grams of salt is already dissolved, then such solution is called as a supersaturated solution. Is this clear to you?
Yes, sir.
Now for example, you see like whenever you have a sweets, okay, like gulab jamun, at that time they'll give one syrup. Yes. So in that, for example, how the syrup contains, for example, if you take one glass of water normally, when you take one glass of water and if you add sugar, so if you add one glass of water and one glass of sugar in that and you stir it, okay, does it dissolve?
No, sir, it makes sense.
Do not dissolve. But when you heat it, so what happens that all okay, sugar will be dissolved in it. Yes or no?
Yes, sir.
So actually now it is dissolved. And now if you see that syrup, then you can see that the amount of solute, means sugar, okay, what is dissolved in it, that is actually more than required for the saturation. Yes or no? Right? So that type of solutions are called supersaturated solutions. Okay, so saturated, unsaturated, supersaturated. Is this clear to you?
Yes, sir.
Yeah. So here, okay, now if you want to take a screenshot or if you want to write the definitions, write it.
Yes, sir.
Finished? Finished? Yes. Shall I rub this one now?
Yes, sir.
Right. Now, so these are classification of solutions based on what? Based on solubility. Yes? Okay, this was based on solubility. But on what factors this solubility depends? Okay, on what factors the solubility depends? Can you say what are the factors that affect the solubility of the solution?
Temperature, stirring,
Temperature?
the pressure. If we stir it, can we dissolve more faster?
Yeah, temperature is one of the factors. More? Yes? Some other factors? Okay, so here some factors, the few factors, important factors we discuss here. So the first one is the nature of a solute. Okay, nature of solute. Second one is nature of solvent. Nature of solvent. Now third one is temperature. Okay, so these are the three factors we are going to discuss today. Okay, so first one, solubility. Okay, factors on which solubility depends. Okay, so factors on which, okay, solubility depends. Okay, so what are the factors here? One is nature of solute, second one is nature of solvent, third one is temperature. Now how this nature of solute depends? Okay, so you know that solute means what? A component which is relatively less in quantity is called a solute, and solid means what? A component which is relatively more in quantity in a solution is called a solvent, right? Now I am going to discuss about the nature of solute. So I am going to discuss how the solubility depends on the nature of the solute. So for this, what I do, I will take okay, so I will take two test tubes here. Okay, so here see, I am taking the two test tubes. Okay, so I'm taking two test tubes. Okay, now what I do, when I'm taking the two test tubes here, okay, now I want to check about the nature of the solute. When I'm going to discuss about the nature of the solute, then I would like to take okay, now what I do, in both the test tube I'll take certain amount of water. Okay, in both the test tube what I'm taking, water.
Yes, sir.
So here water is a solvent. Okay, because I have taken more quantity of water in this test tubes. Yes, so water is a solvent, right? Now what I do, I will take two, okay, substance I'll take. One I will take the salt and second one I will take the naphthalene powder. Okay, the first one what I take? First one I will take the salt. Okay, salt, and the second one I will take naphthalene. You know the naphthalene powder? Yes? Naphthalene balls, you know?
Yes, sir.
So I'll take the naphthalene powder. Now here I will take just 10 grams of salt or 5 grams of salt, and naphthalene also some 5 grams or 10 grams. So certain amount of small amount of salt I am adding here in the first test tube, and a small amount of naphthalene powder also I am adding in this test tube. Okay, so now in both the test tube I am taking two different substances, but whereas the solvent remains same, because we are discussing about the nature of the solute. So when you are discussing about the nature of the solute, the solvent should be common. When you are discussing about the nature of the solute, the solvent should be common. So here I am taking the two test tubes with the same solvent, that is water, but I am taking the two different salts. Like one is okay, I am taking the one is salt and the second one is naphthalene powder. Solutes are different. Okay, now I am adding certain amount of salt in the water, certain amount of naphthalene in okay, here water in the second test tube. Now I will stir it. Okay, I will stir it. Now after few seconds, what will I observe?
Salt dissolves in water, sir.
Salt dissolves. Okay, very good. What about the naphthalene? What about the naphthalene?
Naphthalene water.
Naphthalene will not dissolve. Okay, naphthalene will not dissolve. So here is salt is dissolving in the water, but naphthalene is not dissolving. But in both the cases, the solvent is water. In both the cases, solvent is water, right? But here solutes are different, right? Salt and naphthalene. So salt is dissolving, but naphthalene is not dissolving. So the meaning is what? Here dissolving means solubility is depends on the nature of the solute. Is this clear to you?
Yes, sir.
Like for example, you see, for example, there is one teacher, okay, in a classroom, and the teacher is explaining, delivering, okay, some topic is explaining, okay, to the students. Now 20 students are there. Okay, for example, imagine 20 students are there, and one teacher coming and explaining one topic. Okay, so what is explaining, that is common to all. Yes or no? All the 20 students are explaining commonly in the classroom. Yes. Now immediately after explanation, then tomorrow in the next day he conducts a test. Think that he is conducting a test from the same topic. What did he explain yesterday? Okay. Now whether all the 20 students will get the same marks?
No, sir.
No. Why?
But some write well and some didn't write well, sir.
So here, because that is depends on the nature of the student. Okay, if he is studying well, he is concentrating on the teacher's explanation and is listening and is trying to understand. If you have any doubt, is asking the doubts and clearing his doubts, and those who are interested student is there, and he will score more marks. Okay, and the student is not listening and is not concentrating on the explanation and is not at all studying after going home, so then automatically that naturally will get the less marks. Yes or no?
Yes, sir.
So teacher is same here. Teacher is the same. Explanation part is same. He did not explain anything extra to one student individually. So what he explained throughout the class, he explained the same. Okay, but still the marks, some students are scoring more marks, some students are scoring less marks. That is depend on the nature of the student. Is this clear to you?
Yes, sir.
So similarly, here solvent is common. So solvent is common, that is water. But solutes are different. So salt is dissolving, naphthalene is not dissolving. The meaning is what? It is depends on the nature of the solute. Is this clear to you now?
Yes, sir.
So this experiment shows us that solubility depends on the nature of the solute. Is this clear?
Yes, sir.
Right. Now let's go to the nature of solvent. Now in the nature of solvent, what we do, here we take again same two test tubes. Okay. So here we take the two test tubes. Now we are discussing about what nature of solvent. So what should be taken common here?
Solvent, sir. Salt.
No, solute should be taken common. Yes or no? Here we discussed about the nature of solute. So solvent you are taken common. Both the solvent is same. But here we are discussing about the nature of solvent. So solute should be common, solvent should be different. Yes. So now here what we do? Here I will take the water in both the test tubes. Okay. Sorry. In one test tube I will take the water. And in the second test tube, I'll take the kerosene. Do you know the kerosene?
Yes, sir.
So now in one test tube, I am taking the water, and in the second test tube, I am taking the kerosene. Right? Now, yes, I am discussing about the nature of the solvent. So that's what I have taken the different solvents. Now, what should be taken common? Solute should be taken common, right? So now I take the same solute. For example, I take the naphthalene or salt. Anything you can take. So shall we take salt only? Okay. Then I'll take the salt. In both the test tube, I am taking salt only as a solute. Salt only as a solute. Is this clear to you?
Yes, sir.
So I am taking the two test tubes. In that two test tubes, I am taking two different solvents. In first test tube, I am taking water as a solvent. In the second test tube, I am taking the kerosene as a solvent. Now I am adding salt in one test tube. In both the test tubes, I am adding the salt. Now I will stir in both the cases. Now what I will observe? What will you observe?
The salt dissolves in water and does not dissolve in kerosene.
So salt dissolves in water, okay, but the salt do not dissolve in the kerosene. So salt same, but it is dissolving in the water and it's not dissolving in the kerosene. The meaning is what? Okay, so the solubility is depend on the nature of solvent also. Yes or no?
Yes, sir.
For example, one student is there, and this student having same interest, in two subjects, for example, math and science. Okay, now he is going to mathematics tuition, or mathematics teacher is explaining, and is going to science tuition. And this boy is intelligent and he is doing everything fine. Now he is going for mathematics here, is going for science there. Now for example, you think in one subject he got less marks. Okay, so student efforts are same, but still if he scored less marks means what? Maybe the teacher's explanation may not understanding. Yes or no?
Yes, sir.
So here also the same thing. So here salt is a solute. Solute is same. Solute is common, but solvents are different. Okay. So one solvent it is dissolving means one solvent has the capacity to dissolve the salt and other one do not have the capacity to dissolve the salt. So that is depends on the nature of the solvent. Is this clear to you?
Yes, sir.
Right. Now last and final, let's see the temperature. Okay. So here temperature also one of the factor which affects the solubility. Right. Now for example, just now I gave an example to you, like to take the sugar water. Okay, so take the water. So here you take the 3 test tubes. Okay, so here first we take one test tube, otherwise we take this one. So here we take the water. You take the water, and okay, for example, you think this is 20 ml of water. 20 grams of water or 20 ml, both are same. Okay, 20 grams of water. Now in that I am taking certain amount okay, so imagine that sugar, imagine So for example, like in that maybe some 7 to 8 grams of salt can be dissolved. Okay, at given temperature, means at room temperature, 20 grams of water has the capacity to dissolve like 7 to 8 grams of sugar in it. Okay, but I am adding in that term some 15 grams of sugar here. How much sugar I am adding? 15 grams of sugar I am adding. Okay, now I'll stir it at room temperature, normal temperature. Does it dissolve?
No, how is the capacity, sir?
Its capacity for 20 grams of water, imagine its capacity is 8 grams or 9 grams to its capacity. But now I have added 15 grams in it. Does it dissolve?
No, sir.
No, it will not dissolve. Now for example, I'll take this test tube and heat. Okay, I'm heating. Okay, now on heating, does the salt, the sugar dissolves?
Yes, sir.
Yes, so on heating the sugar dissolves. Now I am increasing the temperature. At room temperature means what? At 30 degrees. Okay, normally at 30 degrees. Okay, normally at 30 degrees means room temperature at 30 degrees. Imagine that this 20 grams of water can dissolve only some 8 to 9 grams of sugar. Okay, but now what I have done? I have increased the temperature from 30 degrees to, for example, 60 degrees. Okay, so 60 degrees. Now the temperature is increased. So then what happens? The sugar is dissolved. So now it dissolved 15 grams of sugar is dissolved in it. Actual capacity is how much? Its actual capacity is only 8 to 9 grams. But how much it is there now? 15 grams of sugar is there. Means what? Excess amount of sugar is dissolved. Okay, so solubility is increased. Yes or no? So temperature is also will affect the solubility. Now here one important point you have to remember. So generally on increasing the temperature, here I give an example that as the temperature increases, solubility also increases. But it is not same for all the substances. Okay, so here sometimes the solubility may increase with the temperature, sometimes the solubility may decreases with the increase in the temperature, and sometimes the solubility may remain constant with the same with the temperature. Okay, for example, if you take the sugar, just now we have taken the sugar, and if you take the sugar solution, then the solubility will be increases with the temperature. Solubility will be increases with the temperature. Okay, but when you take the sodium chloride, means the salt, even if you increase the temperature also, the salt will not increase as much more. Okay, but now some solutions are there where the solubility decreases. For example, you take the soda, you know the soda, drinking soda. Okay, like that will be sold like under brand like okay, Kinley something soda will be there. Yes or no? So in that Kinley soda, that how the soda is made up of? Do you know what is the components present in the soda?
Water and carbon dioxide.
Very good, water and carbon dioxide. Okay, so yeah, carbon dioxide is a solute, water is a solvent. Yes or no?
Yes, sir.
Now if you freeze it, means if you cool it, generally what happens, the carbon dioxide will be dissolved in the water, and that makes the soda. Now if you heat that soda, you take the soda in one beaker and you heat it. Okay, and after heating, then you taste that soda. Does it look like soda?
No, sir.
No. Now you are drinking like water. It looks like water. Why? On heating, the carbon dioxide escaped from the water. Yes or no?
Yes, sir.
So now here when you have taken before heating, the soda is a solution because in the two components are there. Okay, the solubility, certain amount of carbon dioxide is dissolved, so that is solution. But now what happened on heating, the carbon dioxide is going away from it, and after some time the total carbon dioxide is gone. Okay, now it become only solvent. Means what? The solubility is decreased here, increase in temperature with increase in temperature. Is this clear to you?
Yes.
So remember that. So there are three factors, other factors also there, but I am discussing only three factors here. So the three factors depends on three factors the solubility depends. One is nature of solute, nature of solvent, temperature. For temperature also, for some solutions the solubility will be increases, for some substances solubility will remain same, and some substances solubility will be decreases. Is this clear?
Yes, sir.
Right. So if you want to copy, you can copy it. If you want to take a screenshot, you can take a screenshot, because I have one more class. You joined later today. We lost almost 15 minutes class. Okay.
Yes, sir.
Try to join in the correct time. So because I have one more class now, so that's what I am leaving. Okay.
Yes.
Okay, then bye. Yeah, next class will be there. What is the next class today?
Maths, sir.
So maths will come.